Around the world, road technology is quickly evolving. Automated vehicles and driver assistance systems have become widespread across our roads. It is important that OEMs and future law and policymakers are able to collaboratively and proactively make informed choices to develop these rules alongside the progressing technology. This means reliably identifying potential safety pitfalls before road accidents occur. According to the TAC, 90% of crashes in 2016 were caused by human error. Though autonomous vehicles have reduced this number, the fact is that crashes still occur while autonomous driving and driver support systems are in place. In order to prevent these tragic events, researchers, engineers, and analysts must strive to find potential causes and gaps in the availability of relevant data. Our software solution to approach this will be a data visualization dashboard for use by TAC analysts and engineers. The aim is to provide a streamlined environment and powerful correlational tools in order to support assessment and exposure of crash data gaps and related factors. Up to this point, a major part of our work was undertaking in-depth research on current autonomous automotive technologies, focusing on standard and prospective sensors used in the industry, including radar, LiDAR, sonar, and standard imaging. This includes their strengths and weaknesses, applicable scenarios and edge cases, and how the different types are used in conjunction to form a more complete model of the road. In general, the reliability of an autonomous vehicle system is dependent on the effective functionality of its sensors and the system's ability to process incoming data to guide informed decision-making. As such, inaccurate or incomplete sensor technology greatly impacts a system's perception of the road and resultant decision-making, creating an opportunity for road incidents that may otherwise be avoided. There are a multitude of factors that can affect the functionality and reliability of these sensors, including weather and road conditions, construction events, and general hazards. With a tremendous amount of data to consider when solving such a complex problem, it is critical that researchers and analysts using our tool are provided with the most relevant and insightful data available. Our research into the limitations and specifics of automotive sensors has guided us in selecting the related data fields that our dashboard will inherently support. This dashboard, under the tentative name Resin, will provide a range of relevant, visualized information across many crash scenarios, with the option of keying into the intricate details of a single crash. The details of a single crash will provide context and understanding, providing time and weather breakdowns, the make, model, and sensors used on the involved vehicle, and also the extent of the damage and whether the autonomous vehicle was at fault in the incident. Our solution will use a MongoDB database to hold the crash data. Related information such as weather and infrastructure data will be pulled into the dashboard using existing external APIs. The back end of the dashboard will use the Express.js web framework built on top of Node.js. To create a fast and responsive user interface, front-end development will use React.js with extensive use of the Google Maps API. Our team, consisting of Luke, Raba, Felix, Trung, and Corey, all have a solid mix of skills to tackle this task, with experience in front and back-end development, data visualization, and cybersecurity. We are excited about this project and its potential for a positive impact on our roads. The effects of this dashboard may go beyond the technology itself, serving to keep our roads safer and bring the possibilities of autonomous vehicles closer to reality. The dream of autonomous vehicles is near. The risks are not all apparent yet, but this may bring Australia closer to that dream.